In this lecture, we're going to talk about two simple vector operations. One, we will talk about addition of vectors. So we will talk about vectors, laws of additions, and then we will talk about what is the impact of multiplication of a scalar on a vector quantity. So we will start with addition of vectors. So if you have a vector A and a vector B, and if you want to find out what is A vector plus B vector, then there is a rule called triangle rule for addition of vectors. What it says that if you have a vector A and a vector B, and if there is a vector C, which is a third side of a triangle, then C vector is nothing but A vector plus B vector. However, the direction of C vector, so if A vector is going in this direction, B is on this direction. For a normal triangle, you will see C going in the opposite direction of what has been marked. However, the triangle law says that the addition of the vector is A plus B in an opposite direction of the side of a triangle. All vector quantities follow this rule. If there are quantities which has directions and magnitude but do not follow this rule, cannot be said as a vector quantity. Can you think of an example? So what can be example of quantity that has direction and magnitude but do not follow triangle rule of addition? Any thoughts? Okay, I'll tell you the quantity. So it is, say, example is current, right? So in any circuit, current would have a magnitude and it has a direction of flow from high voltage to low voltage. However, it does not follow the triangle rule for addition. What rule does it follow? So there is a rule called Kirchhoff's law, which the addition of current follows, and hence the current is not a vector quantity. So to summarize, a quantity is called a vector quantity if it has a magnitude, direction, and it follows a triangle law of additions. So we'll talk another law which is derived from a triangle law of addition. So if you have a vector A and you have a vector B, and if you complete and assume these are the free vectors, so you can just move vector A and vector B like this. So this is vector A and then this is vector B. Then what the law says is if this is a parallelogram, then C vector is nothing but, which is the diagonal of a parallelogram, is nothing but the sum of a side of a parallelogram. Now this is a derivation from triangle law. So if you assume it is a free vector, you can easily move b vectors instead of starting from an origin O to starting from origin A, and then OAC become a triangle. So angle A plus angle B is basically, vector A plus vector B is same as vector C, right? So this is what it is called. This is called parallelogram law of vector addition. So if you have two sides of a parallelogram, then the diagonal of a parallelogram is the sum of the vectors of its sides. Now let's do a simple problem. If you have point O, point A in x, y, and z plane, so this is A, which is given by x1, x2, x3, and there is a point P, which is given by y1, y2, y3, or let's say, then can you tell me what is the length of AB? You need to find out length of AB. So again, so we have vector OA and vector OB. So we can, by a triangular law of addition, we can say that a vector AB is nothing but an AO vector, which is minus AO vector plus OB vector, right? So we can simply say as AB vector is nothing but, AO vector is nothing but minus OA vector, so it is OB vector minus OA vector, right? Now B vector in this plane can be written as y1 I hat plus y2 j hat plus y3 k hat minus x1 I hat plus x2 j hat plus x3 k hat. Now both y1 and x1 are in the direction of x, so they are parallel vector, so we can simply bring that together. I hat plus y2 minus x2 j hat plus y3 minus x3 k hat, and this is nothing but AB vector. Therefore length of AB vector, which is equals to AB, is the formula that we initially did. So which is y1 minus x1 whole square plus y2 minus x2 whole square plus y3 minus x3 whole square under root, right? So if you know the vector A and vector B, or vector OA or vector OB, you can simply find what is the length of AB using vectors, right? So this is where the triangle law of addition of vector is helpful. So let's talk about our second part of this discussion, which is multiplication of vector by a scalar. So if you have a vector A and you multiply it by 2, if you multiply it by 2, then what is this vector? So this is basically the direction of the vector is not changing. What is changing is only the magnitude of the direction. So we can simply say that this vector is equals to 2a vector. So multiplication of vector by scalar will just increase the magnitude without changing the direction. And we have been seeing this. We have seen this in a vector coordinates where we say if you have a vector A with a1, a2, a3 as the movement in x, y, and z direction, then we simply say that if we know the unit vector in these directions, the value of a in x direction is a1 I hat. So it's a scalar quantity multiplied by a vector quantity whose magnitude is equals to 1 plus a scalar quantity into a vector quantity in that direction with magnitude equals to 1, a scalar quantity with a vector quantity whose magnitude equals to 1. So we are simply using this property of multiplication of vector by scalar in our coordinates system. Another example, if you have a vector and you multiply it by -1, then what will be the resulting vector? Yes, you were right. It is minus a vector. What does that mean? It has the same magnitude, however, its direction is opposite to what the original a vector direction was. So if you multiply it by a negative quantity, it will change the magnitude, but it will also change the direction and goes in the opposite direction of what the original direction was. So we're still on the multiplication of a vector by scalar. So let's talk about another type of vector, which is a collinear vectors. These are vectors which are parallels to each other, right? So a vector, b vector, and c vector are parallel to each other with different magnitudes. So we can say a b vector is equals to k1 a vector, c vector equals to say minus k2 a vector. So if we multiply this by k1 and we get this, and if we multiply by a scalar k2 we get this, but in an opposite direction. So these vectors are called collinear vectors, parallel vectors but with different magnitudes. It can have the same magnitude depending if k1 equals to 1, but it can have opposite directions. These vectors are called collinear vectors. Great. So by this we conclude this video. In the next video we will be talking about position vectors and an important concept called section formula.